Hi, welcome to EasyPeazMaths class. So today we are going to start with chapter 1 exercise 1.1 along with its example. So here is the first example of exercise 1.1. Consider the numbers 4 raised to power n where n is a natural number. Check whether there is any value of n for which 4 raised to power n ends with digit 0. Suppose we are taking these numbers 10, 20, 30 and 50. Do a prime factorization of these numbers. What will be its factors? 2 cross 5, 20, 2 into 2 into 5, 30, 2 into 5 into 3, 50, 2 into 2 into 5 into 5. So what are we observing from this data? 2 cross 5 in each case. So what does this mean? If a number ends with 0, there must be 2 cross 5 as a set as its factors in the prime factorization. Of a number, right? But if 4 raised to power n for any natural number n ends with 0, it would be divisible by 5. This means that four raised to power n should have 5 as its prime number in the factorization, but this is not possible because 4 raised to power n is equals to 2 cross 2 power n, because 4 power n is equals to 2 cross 2 as its factors, not 2 cross 5 as its factors. Also, fundamental theorem of arithmetic, which we earlier read, which we earlier discussed, what it says? As per fundamental theory of arithmetic, the factorization should be unique. As per fundamental theory of arithmetic, the factorization must be unique. So it is not possible that there is any value of n for which 4 raised to power n ends with digit 0. Fine? So in every case, if a number ends with digit 0, it should have 2 cross 5 as its factors. But in this case, 4 to power n was there. What were the factors there? 2 cross 2, not 2 cross 5. So that is why this is not possible that there is any value of n for which 4 is to power n ends with digit 0. Here is the second question. Find the HCF of 96 and 404 by the prime factorization method, hence find their LCM. So first we need to do a prime factorization of these two numbers, 96 and 404. Find their HCF. Fine. So 96 prime factors क्या होंगे? 2, 48, 404, 1. Fine. So what are the prime factors of these? 2 into 2 into 2 into 2 into 3. And here 2 into 2, 101. So what will be the HCF? Take common amongst 2, right? Which is 2 into 2, 4. So here is the HCF of these numbers. Yes, and also find their LCM. So there was one formula, HCF of AB multiplied by LCM of two numbers is equals to product of two numbers, A comma B. What is the HCF of these two numbers? That is 4. And LCM we need to find product of two numbers, the numbers that are given in the question, that is 96 into 404. So LCM will be so what it is 101. 101 into 96 is 9696. So the answer of this is 9696. So your next question is find the HCF and LCM of 6, 72 and 120 using the prime factorization method. 6, 72 and 120. Right? So 6 का क्या होगा? 2 cross 3. And what will be the prime factors of 72? 2, 36, 9, 3, 3, 3, and 120, 60, 2, 30, 15. Correct? So 3 times 2. And 3 times 2, 1 times 3, 5. और कैसे लिख सकते हैं? 2 power 1 into 3 power 1 और 2 power 3, 3 power 2 और 2 power cube into 3 power 1, 5 power 1. Right? So what we need to find? HCF. HCF, take common from all these, like 2 is common amongst all these, 3 is also common amongst all these, right? So what is the answer? 2 into 3, which is 6. And LCM is, LCM कैसे find out करते हैं? The least we can take from these numbers, from these sets, that is 2 cube into 3 square into 5 power 1. So answer is 360. Right? So कुछ बच्चों को ये वाला मेथड एलसीएम निकालने के लिए थोड़ा डिफिकल्ट लगता है, तो इसके लिए मैंने एक अपने प्रीवियस वीडियो में ये बताया था एलसीएम को फाइंड करने का एक अनदर मेथड, दैट इज यू कैन ऑल्सो फाइंड एलसीएम विद दिस वे. You can take LCM of all these. 6, 72 and 120 together. Fine. So what will be the answer? 2, 3, 6, 36, 60. 3, 1, 20, 2, 6, 10, 2, 3, 5, 3, 1, 5, 5, 1, 1. So what is the answer? Answer will be same. That is 2 cube 3 square 5 power 1. Chapter 1 exercise 1.1. So here is the first question. Express each number as a product of its prime factors. So here is the first part, that is 140. We are going to find prime factors of 140. So we are going to check 140 is divisible by 2, gives 70. 70 is also divisible by 2, so 35. 35 is divisible by 5, gives 7. 7 ones are 7. So prime factors of 140 are 2 into 2 into 5 into 7, which is 2 square into 5 into 7. So next part is 156. Same way we are going to do prime factorization of 156. 156 is divisible by 2, which gives 78. Again 78 is divisible by 2, which is 39. 39 is divisible by 3, which gives 13. And 13 ones are 13. So prime factors of 156 are 2 cross 2 cross 3 cross 13, which is 2 square into 3 into 30. Next we have 3825. So this number is divisible by 3 or 5 because the unit digit is 5. So here we are going to apply a divisibility rule. वो कैसे apply किया जाता है? We are going to add these digits individually and we'll check is it divisible by 3 or not. 5 plus 2 7, 7 plus 8 15, 15 plus 3 is 18. So is 18 is divisible by 3? Yes. So this number is divisible by 3. So 3 ones are 3, 3 twos are 6, 3 sevens are 21, 3 fives are 15. So again we are going to check is this number is divisible by 3 or not. Again the same way. 7 plus 5 12, 12 plus 2 is 14, 14 plus 1 is 15. So 15 is divisible by 3, so whole number will be divisible by 3. So 3 fours are 12, 3 twos are 6, 3 fives are 15. Again check with the same way. 5 plus 2 7, 7 plus 4 11. 11 is not divisible by 3, so here the unit digit is 5, so this number will be divisible by 5. 5 8s are 40, 5 5s are 25. Again 85 is divisible by 5, that is 17. 17 ones are 17. So the factors of 3825 are 3 cross 3 cross 5 cross 5 cross 17, which gives 3 square into 5 square into 17. So the next question is 5005. Find the prime factors of 5005. It is divisible by 5, gives 101, 1001. 1001 is divisible by 7, gives 143. 143 is divisible by 11, gives a result of 13. 13 ones are 13. So prime factors of 5005 are 5 cross 7 cross 11 cross 13. And we have next question 7429. Find the prime factors of 7429. So 7429 is a number which is divisible by 70. right? 17, this will give 437, and this number is divisible by 19, gives 23. 23 ones are 23. So what are the prime factors of 7429? 17 cross 19 cross 23. So here is our next question. Second, find the LCM and HCF of the following pairs of integers and verify that LCM cross HCF is equals to product of two numbers. So here is the first part, 26 and 91. First we are going to find the prime factors of 26 and 91. So what are those? 2 ones are 2, 2 threes are 6, 13 ones are 13. And 91, 7 into 13 is 91, 13 ones are 13. So what are the prime factors of 26? 2 into 13, and 91 is equals to 7 into 13. So what is the HCF? HCF is 13 because we are taking common, and LCM is the minimum we can take from these two numbers is 13 cross 2 cross 7, which is 13 into 2, 26. 26 into 7 is 26 into 7 is 7 to the 14, 182. Gives 182. Fine. So also we have to verify the result that LCM cross HCF is equals to product of two numbers. So LCM cross HCF is equals to product of two numbers. What is the LCM? LCM is 182 and HCF is 13. What are the two numbers? 26 and 91, product of these two numbers. So what will be the answer? 182 into 13. 3 2 is 6, 8 3 is 24, 5, 182, 6, 6, which is 2366. 26 into 91 is also 2366. So here our left hand side is equals to right hand side. So second part is 510 and 92. Find the prime factors of both the numbers 510 and 92. 510 is divisible by 2. 2 2s are 4, 2 5s are 10, 2 5s are 10. Again, this number is divisible by 3. 3 8s are 24, 3 5s are 15. This number is divisible by 5, 17. 17 ones are 17. Here is the number 92. 92 is divisible by 2. 2 4s are 8, 2 6s are 12. 2 2s are 4, 2 3s are 6, 23 ones are 23. So what are the factors? 510 is equals to 2 cross 3 cross 5 cross 17, and 92 is equals to 2 cross 2 cross 23. Fine. So what is the HCF? HCF is 2 because we are taking common number, and LCM is, what is the LCM? 2 into 2 into 3 into 5 into 17 into 23. Fine. What is the number? 2 2s are 4, 4 3s are 12, 12 5s are 60. 60 into 17 into 23, which is 1020 into 23. When we are going to multiply 102 and 23, what we are going to get? 3 2s are 6, 0, 3, 2 2s are 4, 0, 2, 6, 4, 2, 3, which is 23460. Fine. And also we have to verify LCM cross HCF is equals to product of two numbers. So how we are going to verify? LCM cross HCF is equals to product of two numbers. What is the LCM? 23460 multiplied by 2, and the numbers are 510 into 92. 2346 multiplied by 2 is 23462. 6 2 is a 12, 1, 4 2 is a 8, 1 9, 3 2 is a 6, 46920, and 510 into 92 is also 46920. So here left hand side is equals to right hand side. So verification is done. Here is the next part. 336 and 54. Again find the prime factors of 336 and 54. 336 is divisible by 2. 2 1s are 2, 2 6 are 12, 2 8s are 16. Again divisible by 2. 2 8s are 16, 2 4s are 8. Again divisible by 2. 2 4s are 8, 2 2s are 4. 42 is also divisible by 2, which gives 21. 21 is divisible by 3, gives 7, 7 1s are 7. 54 is divisible by 2, 2 2s are 4, 2 7s are 14. 27 is divisible by 3, gives 9. 9 is also divisible by 3, 3 1s are 3. So 336 is equals to 54 is equals to, prime factors of 336 are 2 cross 2 cross 2 cross 2 cross 3 cross 7, and factors of 54 are 2 cross 3 cross 3 cross 3. What is the answer? HCF is this common and 3 common. 2 multiplied by 3 is equals to 6. 6 is the HCF. And what is the LCM? LCM is 2 cross 2 cross 2 cross 2 into 3 cross 3 cross 3 cross 7. Fine. So what is the answer? 2 2s are 4, 4 2s are 8, 8 2s are 16. 3 3s are 9, 9 3s are 27 into 7. So what is the answer? 27 into 7 is 7 7s are 49. 7 2s are 14 plus 4, 18, which is 16 into 189. 189 into 16 is 9 6 are 54, 5, 8 6 are 48 plus 5, 53. 5 carry 6 1s are 6 plus 5, 11. 189 into 1 is 189. 4 9 3 12, 10 3 0 2 4. So LCM is 3024. Now we have to verify the result. LCM cross HCF is equals to product of two numbers. So how we will do? HCF cross LCM is equals to product of two numbers. What is the HCF? HCF is 6, LCM is 3024, and product of two numbers is 336 into 54. So what is the answer of 3024 into 6? 3024 into 6 is 6 4s are 24, 2, 6 2s are 12, 2 14, 1, 1, 6 3s are 18. Our answer is 18144. And when you multiply these two numbers, you will get the same result. So here the verification of these two numbers is. The next question is, find the LCM and HCF of the following integers by applying the prime factorization method. So you have to find LCM and HCF of these numbers, right? First find the prime factors of these numbers, 12, 15 and 21. What are the prime factors of 12? 2 6 are 12, 2 3s are 6, 3 1s are 3. And what about 15? 3 5s are 15, 5 1s are 5. What about 21? 3 into 7, 21, 7 1s are 7. So 12 is equals to 2 cross 2 cross 3. 15 is equals to 3 cross 5. 21 is equals to 3 cross 7. So what is the HCF of these numbers? Find the common number, that is 3, and LCM is 2 squared into 3 into 5 into 7, which is 4 into 3 12, 12 5 is a 60, 60 into 7 420 is the answer. And our next question is find the LCM and HCF of 17, 23 and 29. Look at these numbers. These all numbers are prime numbers. So what will be the prime factors of 17? 17 is equals to 17 cross 1. 23 is equals to 23 cross 1. 29 is equals to 29 cross 1. So what will be the HCF? HCF will be 1. And what is the LCM? LCM is equals to 17 cross 23 cross 29. So what will be the answer? Multiply all these numbers and check what will be the result we are going to get. 17 into 23. 17 into 3. 51. 17 2s are 34. 1 9. 391. 391 into 29 is equals to 9. 9 9s are 81. 8. 9 3s are 27 plus 8 35. 2, 9 2s are 18, 1, 3 2s are 6 plus 1, 7, 9, 3, 3 plus 1, 7, 4, 11, 3, 3, 9 is the answer. Next question is find the LCM and HCF of 8, 9 and 25. Find the prime factors of these numbers. What are the factors of 8? 2 cross 2 cross 2, 9, 3 cross 3, 25 is equals to 5 cross 5. Find the HCF. HCF will be, nothing is common amongst these numbers, so HCF is 1, right? Only 1 is common amongst these numbers. And LCM is 2 cube into 3 square into 5 square, which is 8 into 9 into 25. What is the answer? 72 into 25. 72, 25 is 5 2s are 10, 7 5s are 35, 36. 2 2s are 4, 7 2s are 14, 0. Our answer is 1800. So here is the question number 4. Given that HCF of 306, 657 is 9, you have to find the LCM of these two numbers. In our previous video, introduction video, what we discussed, the relationship between HCF and LCM, from there we derived one formula. What was that? HCF of two numbers into LCM of two numbers is equals to product of two numbers. Yes. So here HCF is given. What is the value of HCF? Is 9. We need to find LCM. And product of two numbers are given A comma B, which is 306 multiplied by 657. So LCM of A comma B is equals to 306 multiplied by 657 upon 9. So is 306 is divisible by 9? Yes. 9 3s are 27. 9 4s are 36. So 34 multiplied by 657 is equals to, which is 657 into 34. 7 4s are 28, 2, 5 4s are 20, plus 2, 22. Again 2 carry, 6 4s are 24, plus 2, 26. 7 3s are 21, 2 carry, 5 3s are 15, plus 2, 17. 1 6 is 18, plus 1, 19. 8, 2 plus 1, 3, 7 6, 13, 12, and answer is 2 2 3 3 8. So LCM of these two numbers is 2 2 3 3 8. So here is our next question. Question number 5. Check whether 6 raised to power n can end with digit 0 for any natural number n. So solution is, if 6 raised to power n ends with digit 0, it should be divisible by 5, or you can say it should have 5 as a prime number. But in case of 6 raised to power n, we have 2 cross 3 power n. Therefore, in the prime factorization of 6 raised to power n does not consist 5 as a prime number. So 6 raised to power n cannot end with digit 0 for any natural number n. So our next question is, explain why 7 cross 11 cross 13 plus 13 and 7 cross 6 cross 5 cross 4 cross 3 cross 2 cross 1 plus 5 are composite numbers. So how to solve this question? Right, first part, 7 cross 11 cross 13 plus 13. So what is common? 13 is common. So what is left inside in the bracket? 7 into 11 plus 1, which is 13. 11 into 7 is 77 plus 1. 13 multiplied by 78. So what are the factors of 78? 2. 39. 39 is divisible by 3, which is 13. 1. 13 into prime factors of 78 are 2 cross 3 cross 13. So what are you finding here? As the question is asking, is this a number, a composite number? What was the definition of composite numbers? Composite numbers are the numbers who have more than 2 factors. So in this result, we have more than 2 factors. So we can say that this number is a composite number. So yes, 7 cross 11 cross 13 plus 13 is a composite number. Similarly, do a second part in a similar way. So what are the numbers? 7 cross 6 cross 5 cross 4 cross 3 cross 2 cross 1 plus 5. Yes. So what is the common amongst these numbers? For number 5, what is left behind inside the bracket? 7 cross 6 cross 4 cross 3 cross 2 cross 1 plus 1. So what is the number? 5. 7 into 6, 42. 42 into 4 3 is a 12. 12 2 is a 24 plus 1. So we are getting 1009. So this is also a composite number because this number have more than 2 factors. So yes, seven cross 6 cross 3 cross 2 cross 1 plus 1 are composite numbers. Next question is question number 7. There is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time go in the same direction. After how many minutes will they meet again at the starting point? So what is the question saying? There is a circular path. Sonia takes 18 minutes and there is one more person, Ravi. Ravi takes 12 minutes to cover this circular path. Both move in the same direction. Yes? So what you need to find, after how many minutes will they meet again at this starting point? So how will you find? इस क्वेश्चन में मोस्टली स्टूडेंट्स कंफ्यूज होते हैं कि हम इसमें एचसीएफ लगाएं या एलसीएम लगाएं. आप क्वेश्चन को ध्यान से ऑब्जर्व कीजिए. अगर सोनिया 18 मिनट्स लगा रही है तो रवि 12 मिनट्स लगा रहा है, कम टाइम ले रहा है उसी सेम पॉइंट पे पहुंचने के लिए. यस, तो जब ये दोनों 1 राउंड 2 राउंड 3 राउंड्स कुछ राउंड्स कंप्लीट करेंगे तो अगर आप चेक करें तो वो जो टाइम आएगा दोबारा जब वो सेम पॉइंट पे मिलेंगे तो वो 18 मिनट से ज्यादा होगा. यस, जो नंबर आएगा वो 18 मिनट से ज्यादा होगा. अगर आप इस पे एचसीएफ अप्लाई करते हो तो ऑब्वियसली नंबर विल बी लाइक 3 4 18 से कम आएगा. यस, बट as the question demands, the minimum time they meet again at the starting point. Minimum time they take to cover this whole circular path, right? To meet at the starting point, that we will find with the help of LCM, because LCM gives you a time more than 18 minutes. So that is why we are going to apply LCM of 12, 18. Right? So how to find LCM? With the prime factorization method. 2, 6, 2 9s are 18, 3 2s are 6, 3 3s are 9, 2 1, 3 1, right? So what is the LCM? Factors of these 12, 18, 2 cross 2 cross 3 cross 3. Which is 2 square into 3 square. Answer is 36. So after how many minutes they will meet again at the starting point? After 36 minutes they will meet again at the starting point. To start with exercise 1.2 examples, but before starting with examples, let's understand this theorem. What it says: let P be a prime number if P divides A square, then P divides A, where A is a positive integer. What it says: P is a prime number and A is any positive integer. Let's understand this theorem by taking an example. Suppose 2 is a prime number and a is any positive integer. Let's say it's 4. What it says, if p divides a square, if prime number is divisible by square of any positive integer, which is true, then it is divisible by a also. That's correct. If p divides a square, then p divides a also, which is true. Here check, 16 is divisible by 2, then 4 is also divisible by 2. So exercise 1.2 questions are based on this theorem. Here is the exercise 1.2 examples. Question number 1 is, prove that root 2 is irrational. Here is the exercise 1.2 examples. Question number 1, prove that root 2 is irrational. Suppose root 2 is a rational number where a and b are co-primes. What are co-prime numbers? Co-prime numbers are those numbers whose HCF is 1. Right? Can we write this number as root 2b is equals to a square? Both sides we get a square. 2b square is equals to a square. So what you observe here? A square is divisible by 2. 2 divides a square. Therefore, 2 divides a also. Yes. Make it equation 1. Let a is equals to 2c for some integer c. Put the value of a in equation 1. We get, अगर आप इसको a की वैल्यू को पुट करोगे इस इक्वेशन में, what you will get? 2b square is equals to 2c whole square. Correct? Which is equals to 2b square is equals to 4c square. B square is equals to 2 square because this cancel out. Right? Here what you observe? 2 is divisible by b square. 2 divides b square, then 2 divides b also. Make it a second equation. From 1 and 2, what we observe? From 1 and 2, 2 is a common factor in these two cases. 2 is a common factor. Therefore, this contradicts our assumption hence root 2 is irrational. Question number 2 is, prove that root 3 is irrational number. Suppose root 3 is a rational number where A and B are co-prime numbers. Co-prime numbers are those numbers whose HCF is 1. Can we write this equation as root 3b is equals to A? Square both sides, we get root 3b whole square A square, we get 3b square is equals to A square. So what you observe from this equation is A square is divisible by 3. 3 divides A square, therefore 3 divides A. Make it first equation. Let A is equals to 3C. For some integer C, put the value of A in equation 1. In this equation, we get 3b square is equals to 3c whole square, 3b square is equals to 9c square, b square is equals to 3c square. Here what you observe? B is divisible by 3. 3 divides B square, therefore 3 divides B also. Make it second equation. From 1 and 2, we get 3 as a common factor. Therefore, this contradicts our assumed assumption. Why? Because what we assumed, A and B are co-prime numbers, can having a common factor of 1 only. But what we get at the end, 3 as a common factor. So hence our assumption is contradicted. Therefore, root 3 is irrational. Question number 3. Prove that 5 minus root 3 is irrational. Suppose 5 minus root 3 is a rational number where A and B are co-primes and can we write this equation as 5 minus A minus B is equals to root 3, which is equals to 5b minus of A upon B is equals to root 3. Yes, if 5b by minus A upon B is rational, therefore root 3 is also rational as per the equation number 1. But root 3 is irrational. Also, rational number cannot be equal to irrational number. Yes? So here contradiction has arisen. What we assume that 5 minus root 3 is a rational number. But here root 3 is a irrational number. Therefore, this contradicts our incorrect assumption that 5 minus root 3 is rational Hence we conclude five minus root 3 is irrational. Question number 4. Prove that 3 root 2 is irrational. Assume 3 root 2 is a rational number where A and B are co-primes and B is not equals to 0. Rearrange these values. What we get? Root 2 is equals to A by 3B. Yes? So from this equation what we observe? A by 3B is a rational number. So root 2 is also a rational number. But root 2 is irrational. Also, rational number cannot be equal to irrational number. Therefore, this contradicts our incorrect assumption that 3 root 2 is rational. Hence, we conclude 3 root 2 is irrational number. Here is our first question. Prove that root 5 is irrational number. Suppose root 5 is a rational number where A and B are co-primes and B is not equals to 0. Rearrange this value. What we get? Root 5B is equals to A. Square both sides. We get 5B square is equals to A square. So from this equation what we observe? A square is divisible by 5. 5 divides A square, therefore 5 divides A. And here A is any positive integer. Let A is equals to 5C for some integer C. Make this equation as first equation and put the value of A in equation 1. We get 5B square is equals to 5C whole square, which is equals to 5B square is equals to 25C square. B square is equals to 5C square. So from this equation, what we observed? B square is divisible by 5. Therefore, 5 divides B square. Therefore, 5 divides B also. Make it second equation. From 1 and 2, what we observed? 5 has a common factor in both the cases. Therefore, this contradicts our incorrect assumption. Contradicts our incorrect assumption that A and B are co-primes, but here what we are getting, 5 as a common factor, hence root 5 is irrational. So here is our second question. Prove that 3 plus 2 root 5 is irrational. Suppose 3 plus 2 root 5 is a rational number where A and B are co-primes and B is not equals to 0. Rearrange these values. What you get? 2 root 5 is equals to A by B minus 3. Take LCM of this. 2 root 5 is equals to A minus 3B upon B. Yes. Can we write it as root 5 is equals to A minus 3B upon 2B? Correct? Make it first equation. From first equation, what we are observing? A minus 3B upon 2B is a rational number. Therefore, root 5 is also a rational number. From first, we observed that A minus 3B upon 2B is rational. So, root 5 is also rational. But root 5 is irrational number. So this contradicts our assumption that 3 plus 2 root 5 is rational number. So this contradicts our assumption that 3 plus 2 root 5 is rational number. Hence, 3 plus 2 root 5 is irrational. Question number 3 is prove that following are irrationals. First part is 1 by root 2. Suppose 1 by root 2 is a rational number where A and B are co-primes and B is not equals to 0. Rearrange these values. Can we write it as B is equals to root 2A? Also B by A is equals to root 2. Here, make it first equation. From first, we observe that B by A is a rational. So, root 2 is rational. But root 2 is irrational. So here is contradiction. B by A is rational, therefore root 2 is also rational, and rational number cannot be equal to irrational number because root 2 is irrational. So this contradicts our assumption that 1 by root 2 is rational, hence we conclude 1 by root 2 is irrational. Second part, 7 root 5. Prove 7 root 5 is irrational. Suppose 7 root 5 is a rational number. A and B are co-prime numbers and B is not equals to 0. Rearrange this value, what we get? Root 5 is equals to A by 7B. From this equation, what we observed? A by 7B is a rational number, so root 5 is also a rational number. But rational number cannot be equal to irrational. Also, root 5 is irrational. Therefore, this contradicts our assumption. Therefore, this contradicts our incorrect assumption that 7 root 5 is rational. Hence, 7 root 5 is irrational number. Question number 3, part 3. Prove that 6 plus root 2 is irrational number. Initially, we assume that 6 plus root 2 is a rational number. Therefore, 6 plus root 2 is equals to A by B, where A and B are co-prime numbers and B is not equals to 0. Rearrange these values, what we get? Root 2 is equals to A by B minus of 6, and take the LCM of this right hand side part, what we get? Root 2 is equals to A minus 6B upon B, and make it equation 1. So from 1, what we observed, from 1 we observed that A minus 6B upon B is a rational. So root 2 is also a rational, but root 2 is irrational number. Also, irrational number cannot be equal to rational number. Therefore, this contradicts our incorrect assumption. That 6 plus root 2 is rational. Hence, we conclude 6 plus root 2 is irrational.